Let's analyze a two-input neuron with different transfer functions. We're given bias B equals -1.8, weights W1 equals 0.5 and W2 equals 1.2, and inputs P1 equals -2 and P2 equals 3. First, we calculate the net input n using the formula n equals W1 times P1 plus W2 times P2 plus B. Substituting the values, n equals 0.5 times -2 plus 1.2 times 3 plus -1.8. This equals -1 plus 3.6 minus 1.8, which equals 0.8. Now let's compute the output using a symmetrical hard limit transfer function. This function outputs 1 if the input is greater than or equal to 0, and -1 otherwise. Since our net input n equals 0.8, which is greater than 0, the output is 1. Next, let's use a saturating linear transfer function. This function outputs 0 for inputs less than 0, the input itself for inputs between 0 and 1 for inputs greater than 1. Our net input is 0.8, which is between 0 and 1, so the output equals the input itself, 0.8. Finally, let's use the hyperbolic tangent sigmoid transfer function. This function maps inputs to values between -1 and 1 using the formula tan h of n equals e to the n minus e to the negative n, divided by e to the n plus e to the negative n. For n equals 0.8, we compute tan h of 0.8, using the formula or a calculator. This equals approximately 0.664. Let's visualize these transfer functions with graphs to better understand their behavior. We've computed the neuron output for 3 different transfer functions. HardLims gives 1, SATLIN gives 0.8, and TANSIG gives approximately 0.664.